Okay, so we are looking at algebraic identities, and here we have a fraction and it's equal to two separate fractions being added together. And it says if this is equal to this and this for all values of x, then find the values of a and b. Just like every time we are looking at algebraic identities, guys, we want the two sides to be in the same form. So over here I have one fraction, over here I have two separate fractions, and they need to be added together. So we can see there, like, if I was to join these together, my common denominator would be the x plus 1 by the x minus 1. Okay, that will get me this common denominator that's the same on the other side. So start by doing that, okay? It doesn't even matter if you can't see how you're going to finish this. We want to get them to look the same, to take on that same form. So my left hand side, I'm not going to change anything about it for now. Okay, I'm literally just going to keep it the exact same. So it's 1 over x plus 1 times an x minus 1. And then that is equal to, and I want to rewrite this, but with a new denominator. So my new denominator is the x plus 1 times the x minus 1. So just to make it really clear, I'm actually going to just write these out as two separate things with the common denominator firstly. So I had an a over x plus 1, and I had a b over x minus 1. Okay, and we said that my new denominator is x plus 1 times x minus 1, which means I need to multiply that by an x minus 1, and I also need to multiply the top line by x minus 1. And over here I need to multiply this by x plus 1, which means I also need to multiply the top line by x plus 1. Okay, so now I can see if I was to join those together. Okay, so they have a common denominator, so I can write the top lines together with the common denominator written once. So I'm going to have a by x minus 1 plus b by x plus 1. Okay, and that line is over the full, underneath the full top line. Okay, that is what my left-hand side is equal to. So 1 over x plus 1 by x minus 1. Okay, so we can see now that they have the same denominator on both sides. Okay, I can multiply both sides by the x plus 1 and x minus 1 to just get the numerators equal to each other. Okay, or we can just compare both sides. The bottoms are the same, which means the tops must be the same. Okay, so 1 on the bottom must be, 1 from the top must be equal to the top line on the other side. So the a by the x minus 1 plus b by x plus 1. Okay, you can think about this as if it's like cross multiplying, but then again, if you were to cross multiply these, this will be multiplying all this and this will be multiplying all this. We could just cancel. Okay, or they have the exact same denominator and there's an equals. Okay, when there's an equals and everything has the same denominator, it cancels. Okay, so now when we look at this, okay, we have an equation with a and b. Okay, usually we can't find two unknowns with just one equation. But, and this is the key part in algebraic identities, it says that this is the case for all values of x. So I have an a here and I have a b here, but I can figure out a way to basically cancel one of these, to be able to ignore one of these. Okay, and the way to do that is to have one of these things multiply by 0. Okay, if I multiply this a by 0, then I'll just be left with an equation in b. Okay, how can I do that? Well, it said it's for all values of x. So I can say, okay, well, what about the case when x is equal to, okay, what would x have to be equal to here to make this bracket equal to 0? It will be 1. Okay, so if I said, okay, well, what about the case when x is equal to 1? Then I'm going to have 1 is equal to a times 0 plus b times 2. Okay, so that way I know that 1 is 2b And I can find b by dividing by 2, so a half is equal to b. Okay, likewise, so that was my one when I said that x was equal to 1. I can do the exact same thing and say that, okay, well, x is equal to, how do I figure out, how do I get this bracket to be 0? Okay, well, I'd have x being minus 1. So 2 different ways I can get a now. I could sub back in my value for b. But to be honest, I'd still be left with a and x. Okay, so you could sub that back in and see how far you can get. And that's going to help you towards being able to verify your answer. Or here, okay, nice and easy way of doing it. Get the b to multiply by 0. So make x be minus 1. So that we're going to have 1 is equal to a times a minus 2 plus b times 0. So 1 is minus 2a, so minus a half is a. Okay, so to verify your answer, both of these should sub in here and allow this full equation to be equal to 1. Okay, so minus a half by x minus 1, so minus a half x plus a half, and then here plus a half x plus a half. So the x's will cancel, and then I'd have plus a half, which is equal to 1. Okay,